Hello. I'm here to show you how to graph parabolas. So I gave you, number one, your standard parabola that you always use to graph other parabolas with different transformations. Example number 2, example number 3, example number 4. So what we'll do, we'll go to your standard parabola, which is your reference when you're graphing any kind of parabolas. You have the equation y equals x squared. When you're graphing any kind of equation, what you're taught in grade 9 on how to use table of values always works. So again, let's go back and look at parabolas. Parabolas in vertex form are written as y equals a x minus p close the bracket squared plus q. Every parabola has a vertex, and the vertex is always the p and the q value, which are right here. And every parabola has an axis of symmetry. Means there's a line acts as a mirror that show you the right side of the parabola will equal the same, or the same, or it would be the same as the left side of the parabola. So it would just be a reflection in that mirror. So y equals x squared is a parabola that has a vertex of 0, 0. So what I do, I write this point right here in my table of values. That's where I start. And then I go to the x values and I choose two values that are next to the 0, so 1 and 2. Plug them back into the equation and solve for y. So that's the x value 1. If you sub it in here, 1 squared is 1. Therefore, y is 1. For the other value, the x value is 2. You sub it in here. 2 squared is 4, so you get a 4. Yeah. Now let's just draw a grid and plot my vertex first. There's my vertex right there. Also, I'm just gonna say the axis of symmetry, and for this one is x equals 0, because that's x equals the p-value, and the p-value always this part of the vertex. Okay, so basically this means my y-axis here is going to be the axis of symmetry. Okay, so it's the x equals 0 is basically saying the y-axis. So now I plotted my vertex, which is 0 and 0, and then let's go plot the next point, which is 1 and 1, and then plot the other point, which is 2 and 4, which is right there. Now, when I plot these 2 points, all I need to do now, just look at the axis of symmetry, reflect this point into the axis of symmetry. So that's your other point. Reflect this point also in the axis of symmetry. As you see, it's at 4 and it's 1, 2 away from the axis of symmetry. So you go 1, 2 away and you have your other point. And therefore, now you have your parabola, right? Sorry, just I'm getting used to this pen right here. So this is your parabola right there. This parabola right there is the parabola that we refer to when we're graphing any other graph. And I follow the same thing. So now that we graphed the first one, and keeping in mind, this is how a parabola looks like, where the vertex is 0, 0, and you have this kind of shape. I'm just gonna erase the first parabola and graph the second one. using the same method. Okay, so just let's go, and again, I'm just gonna keep my table of values. So I'm gonna take number 2, which is y equals 2x squared minus 1. The vertex here is 0 and negative 1. Now, you might come and ask me and say, how did you get that? So let's write this equation in this format right here. So basically, if we want to write it in that format to see how we get the 0 and negative 1, then y equals 2x, brackets x, minus 0 squared. Oops. Sorry, let me just undo that. Okay, so sorry, x minus 0 squared minus 1. And that's how we get the vertex. When it's x and there's nothing with the x and it's squared, it's the same as x minus 0 squared. You don't have to write it in this form. When you see a parabola written like this, just know the p-value is 0, and that's why the square is only on the x and there's no brackets. So again, I follow the same procedure. The first thing I put in here is 0 and negative 1. And then I take the two numbers that are next to 0 and the x as x values. So 1 and 2 again here. I take this one, sub it into here. 1 squared is 1 times 2 is 2 minus 1 is 1. So I have 1 right here. Then I take the 2, sub it into the equation again, original equation here. And if you go 2 squared, 4 times 2 is 8, minus 1 is 7. And we have that. Yeah. So again, I'm going to come here and graph this xy. One, negative 1, negative 2, 2, and so on. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, and so on. So again, I graph, first thing I graph my vertex, which is 0 and negative 1. So 0 and negative 1 is right here. That's where my vertex is. My axis of symmetry again. Axis of symmetry. So we're just going to say A, O, S is x again equals 0 because it's x equals p, and the p again is 0. So again, my y-axis is my axis of symmetry. I'm going to plot the next point, which is 1 and 1, and then the 2 and 7, which is right there. And then just take these 2 points, reflect them into the axis of symmetry. So 1 away, you go 1 away, and you have your next point. And then this is 1, 2 away, so you go 1, 2 away, and you have your other point. Bingo. I have my parabola right there. Sorry, I'm just getting used to using this pen. It's kind of awkward. And this is my second parabola. Now, let's go erase this. And what we'll do is we'll graph the next parabola. Yeah, so my next parabola is number 3, and it is y equals 2x minus 1 squared now. My vertex here is 1 and 0, because as you notice, we have the P, which is the 1, and the Q, there's no Q there, so that indicates that the Q is 0. So my vertex is 1 and 0. So that's the first thing I do. I put my vertex there, then I go to the X value and choose the two next X values to 1, which is the 2 and the 3 after the 1. Take this 2, plug it back into the equation. 2 minus 1 is 1, 1 squared is 1, times 2 is 2. Order of operations, okay. Take the 3, sub it into here. 3 minus 1 is 2, 2 squared is 4, times 2 is 8. I plot my grid x-axis, y-axis. Maybe just make it a bit longer. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first thing I plot is my axis of symmetry, which is at 1 and 0. So that's my axis of symmetry here. What you could do, you could draw a dotted line indicating your axis of symmetry. Yeah. Now you plot the next 2 points, which is 2 and 2. So 2 and 2 is right there. And then 3 and 3 and 8, which is right there. So now once you have these 3 points, you go to your points right here and reflect them into the axis symmetry. So that's 1 away from the axis symmetry, you go 1 away and you have your other point. And then this is 1, 2 away, so you go 1, 2 away and you have your next point. And therefore now, all you need to do is just go ahead and graph the parabola. Sorry, it's just a bit off there. And then again, sorry, I just, again, I'm getting used to this pen right here. Let me just erase some of that and do it again. All right. Wow. And there you go. Looks a bit off, but this is how you graph the third parabola. So now let's go to the next one. Let's erase, or the last one, erase the and then the your fourth and last parabola is parabola number 4. It's y. And you know what? I'm just gonna make it plus here. Yeah, just to change a little bit there. Y equals -2 x plus 1 squared plus 3. So first thing is vertex. Vertex is P and Q. Okay, P and Q. And P is -1. And Q is 3. So the vertex is -1 and 3. Right there. Axis of symmetry is y equals, sorry, x equals -1. Now, once I put my vertex right there, the x and the y value, or the p and q, all I need to do is just choose the two next numbers to -1, which is 0 and 1. Take the 0, sub it back into the equation, an order of operations. So 0 plus 1 is 1. And then you square the 1, you get 1. Times -2 is -2, plus 3 gives you 1. And that's the next point. And then take the 1, sub it into here. For the x, 1 plus 1 is 2. And then you have to square the 2. That's 4 times -2 is -8. Plus 3 is -5. So that's what I get. Okay. Now, I need to go and graph this. Um, 1, 2, 3, 4, -1, -2, -3, -4, -5. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Now, I plot my vertex, which is at -1 and 3, right there. Now, of course, through this point is my axis symmetry, so it's just going to be a dotted line through that point. Yeah. And then I plot my other 2 points. We have 0 and 1, which is right there, and 1 and -5, which is right there. After this, all I need to do is just take this point, the 0 and 1, reflect it into the axis symmetry. It's 1 away from the axis symmetry, so you go 1 away and you have your other point. And then this point also is 2 away from the axis symmetry, so you go 1, 2 away and you have your other point. And this is your parabola. Excuse my drawing, I'm just still getting used to this pencil right here, the electronic pencil. And this is how your parabola looks like. All right. So what the A in here, what the A does in here is basically it shows you the expansion and compression vertically and the direction of opening. Okay, so this indicates if the parabola is opening up or opening down. So if this value is positive, if the A is positive, your parabolas will open up, as we had in all first 3. If it's negative, as you notice, your parabola is opening down. When you do table of values, that always work for any kind of graphs. When you get to higher level graphs, you could always do them using the techniques that you're given, but you could always go back to table of values to double check if what you've done is right or not. All right. So parabolas open up or down. If the parabola opens down, you have a maximum value right there. But if it's opening up, you'll have a minimum value. And that's another lesson altogether. It's just a simple way of graphing parabolas, or a different way, if I may say. There are guys who memorize, the out 1, up 1, and then out 1, up 3, and all of that. It works, but I think getting used to table of values and trying to do it that way is also fine. I hope you like this method. The next time, I'll talk to you later. Take care. Bye-bye.